Assalamualaikum warahmatullahi wabarakatuh. Okay, today we will learn about chapter 2, kinematics. Okay, firstly, we look at the learning outcome. Number 1 is to be able to define and identify vector and scalar quantities. Number 2, able to define and solve linear motion problems. And number 3, able to explain and solve acceleration due to gravity. Okay, the first one, we want to know about vector and scalar and linear motion parameters. Okay, so for vector and scalar, vector is a physical quantity that have both magnitude and direction along with the units. Examples: displacement, velocity, and force. For scalar, it is a physical quantity that have magnitude only, along with the units. Examples: distance, speed, and temperature. For linear motion parameters, we start off with distance. It is a scalar quantity. It is defined as the total path length traversed in moving from one location to another. For displacement, it is a vector quantity. It is defined as the change in position from the initial position xi to the final position xf. The equation delta f is equal to xf minus xi. It is actually the straight line distance between xi and xf. For speed, it is a scalar quantity. It is the rate of change in position of the object when it is in motion. Whereas for velocity, it is a vector quantity. It is the rate of change in position of the object when it is in motion, and it tells how fast and in what direction the object is moving. The equation for speed, the average speed is given by distance over total time, whereas for velocity, the average velocity is given by displacement over total time. The last one is the acceleration. It is a vector quantity. The rate of change of velocity of the object. The equation for acceleration is delta v over delta t, v minus u over t, delta t minus t naught, where u is the initial velocity at t time t naught, and v is the final velocity at time t. We look at example 1. A motorist drives north for 0.5 hours at 85 km per hour and then stops for 15 minutes. He then continues west, traveling 130 kilometers in 2 hours. A. Compute his total distance. B. Compute his total displacement. And C. Compute his average velocity. For total distance, we separate the path into two, which is A due north and B due west. For due north, the information given are the motorist travels at 85 kilometers per hour for 0.5 hours. So from the information, we can calculate the distance, which is 42.5 kilometers. For distance B, it is given to us that the motorist travels due west for 130 kilometers. So we sum up between distance A and B to get the total distance of 172.5 kilometers. For total displacement, okay, so since displacement is a vector, so we have to take into account the direction. Okay, please remember the definition for displacement is the straight line distance between start to finish. So from the path traveled by the motorist, we can see that 42.5 kilometers due north and then 130 kilometers due west. So we can draw a path uh, to get the straight line distance uh, for the motorist. Okay, here we can see it. We get a shape of a right angle triangle, so we can use Pythagorean theorem to calculate the total displacement of 136.77 kilometers. And the last one is the average velocity. It is the total displacement over total time. So we get 54.71 kilometers. Example 2. An automobile traveling on a straight road at 90 kilometers per hour slows down to 40 kilometers per hour in 5 seconds. Computes its average acceleration. Okay. So firstly, from the information of velocities given, so we convert the units of the velocities into SI units, where the initial velocity u given 90 kilometers per hour converted into 25 meter per second, for final velocity v at 40 kilometers per hour converted into 11 meter per second. Then we use the equation for acceleration, the rate of change of velocity, delta v over delta t, to get negative 2.8 meter per second squared. The negative sign indicates the object is slowing down. It does not indicate the direction of motion of the object. Thank you for your attention. See you in our next video. We will discuss graphs in linear motion.